Hello, I'm Sanjeev Lalwani, Chief Strategy Officer at Lynntech. We are based in College Station, Texas. This presentation covers our work on a retrofittable high-power kit for the JLTV. As modern mission systems evolve, vehicle platforms are being asked to deliver significantly more onboard and exportable electrical power than they were originally designed to provide. Today, I'll be discussing an integrated high-power generation solution designed to enhance the electrical capability of the Joint Light Tactical Vehicle, or JLTV. In this presentation, I'll walk through the following: the operational need driving this effort, the technical approach we've developed, the current maturity of the system, and how this capability can transition into operational use. Lynntech was founded in 1987 with a mission to nurture and harvest scientific creativity into life-changing technologies. We are about 110-person strong advanced technology development company with deep experience in power systems, ruggedized electronics, materials science, and integrated systems engineering. We maintain over 66,000 square feet of facilities, including approximately 45,000 square feet of laboratory space. Our team includes more than 30 engineers, roughly 25 PhDs, and dedicated commercialization and manufacturing professionals. Importantly, we have a proven track record of moving technology from early-stage R&D through commercialization and government transition. We were honored with the 2016 Tibbets Award for outstanding contribution to the SBIR program. For this specific effort, we are combining deep power systems expertise with practical vehicle integration experience to solve a real operational problem for the Marine Corps and potentially the broader DoD fleet. The Marine Corps objective is clear: to develop an integrated, compact, prime engine-driven high-power generation system for the JLTV. Modern mission systems are driving significantly higher electrical loads in the field. The existing JLTV platform generates approximately 12.8 to 14.6 kilowatts of electrical power. That capacity was not designed for high-energy weapons, advanced counter-UAS systems, etc. Standalone generators create both tactical and logistical challenges. A 60-kilowatt generator set can weigh approximately 4,000 pounds and requires towing, dedicated logistics support, and additional fuel planning, all of which can significantly impact mobility, operational flexibility, and ultimately mission success. So the requirement becomes multidimensional, including increase onboard and export power, maintain mobility and cargo capacity, avoid adding mission burden, preserve vehicle reliability, and enable scalable growth for future technologies. Our approach directly addresses these constraints. Lynntech has developed a retrofittable high-power kit that increases JLTV export power capability by approximately 50 kilowatts. Instead of replacing the existing alternator, we complement it. The vehicle maintains its baseline electrical system while adding a mechanically driven high-power generator through the transmission power takeoff. There is an available 30-kilowatt alternator replacement, but net usable power remains limited because vehicle systems consume a portion of that capacity. Our solution provides true additional export power. Operationally, this enables ground-based air defense, counter-UAS systems, M-directed energy applications, and command and control systems, all without requiring a trailer-mounted generator. Key features and benefits of Lynntech's retrofittable kit are listed in this slide. In particular, I'd like to highlight a few elements that differentiate this solution. First, this is a transmission power takeoff-driven architecture. That means we are leveraging the vehicle's existing prime mover to generate substantial exportable electrical power without redesigning the baseline electrical system. We are adding capability, not replacing or disrupting what already works. Second, the system is designed as a compact, sealed, liquid-cooled unit. This enables higher power density, improved thermal management, and quieter operation, all critical in tactical environments where signature and reliability matter. And third, the kit is engineered as a bolt-on solution with intelligent load management. It automatically responds to power demand while protecting drivetrain components through electronic torque control. That balance between performance and protection is essential for fielded platforms. Taken together, these features position Lynntech's retrofittable kit as an ideal solution to the Marine Corps' need for additional electrical output power from the JLTV. We have made significant progress towards demonstrating this kit to the Marine Corps. Specifically, system requirements have been clearly identified and quantified. Alpha prototype design for JLTV integration began ahead of schedule. Further, we have demonstrated scaled power capability via breadboard hardware and are currently at technology readiness level 4, targeting TRL5 by project conclusion. Given significant transition potential programs of record have been identified, such as PEO land systems under Marine Corps, Systems Command, Ground-Based Air Defense, and Army JPO, JLTV. Overall, we are methodically reducing technical risk while positioning for successful transition. This slide really comes down to capability versus requirement. There are solutions in the market that offer incremental increases in electrical output, but incremental gains are not what the Marine Corps is going to need to support future high-value mission systems. Contrary to commercial solution offerings, we are not pursuing incremental alternator improvements, and we are not adding complexity that burdens the vehicle with extra weight, space constraints, or architectural stress. Our approach is engineered to increase power without creating new limitations. So, the real question is, does the solution deliver meaningful, scalable export power while preserving mobility and platform integrity? That's the gap we are addressing. Lynntech's Retrofittable kit is designed from the outset to provide substantial additional electrical output, not just a marginal bump, and to do so in a way that integrates cleanly with the existing vehicle platform. To transition beyond Phase 2, we've identified that follow-on funding will be needed. Specifically, a Phase 2.5 SBIR effort should help us further mature and ruggedize the technology. Additionally, to the best of our abilities, we are aligning technical maturity with programmatic sponsorship. While we understand that the current sponsor is Marcor Syscom, to our knowledge, the Army has also been engaged through JPO, JLTV. We think the best next steps include the following: achieving higher TRL, conducting operational environment testing, potentially at APG, and finalizing integration pathways. It is our understanding that our primary transition advocates include Marcor Syscom, PEO Land Systems, PMGBAD, and potentially Army JPO, JLTV. Beyond the Marine Corps, this capability has significant dual-use potential. As the demand for portable mobile electrical power increases across defense and commercial sectors, integrated vehicle-based power becomes a strategic enabler. Lynntech's Retrofittable kit functions as a PTO-based power generation system. This could translate further to the following: tow trucks recharging EVs in remote locations, electrified tow trucks replacing hydraulic systems, law enforcement and search and rescue vehicles, heavy machinery and tractor trailers, and finally, disaster relief power delivery. This is not just a Marine Corps solution. We believe this is a scalable power architecture. In closing, we see several transition avenues. Our strategy is collaborative integration, not standalone development. We want to move this into fleet platforms through structured partnership. Sequential funding through Marcor Syscom and Army JPO, JLTV, engagement with the Prime to support integration, and/or Program Office Prime Lynntech collaboration to leverage existing vehicle contracts for technology insertion. We also have strategic partners that would be important going forward, such as Parker Chelsea, an American-based PTO manufacturer, and NATC as a potential ruggedization evaluator. To conclude, modern military operations are becoming increasingly power-intensive. Electrical demand at the tactical edge continues to grow as new mission systems are integrated onto existing platforms. Military vehicles, including the JLTV, represent a key area where innovation can support those requirements with scalable onboard power generation. Lynntech's Retrofittable high-power kit for JLTVs delivers the following: approximately 50 kilowatts of exportable power, minimal additional weight, no external support equipment, preserved mobility and platform integrity, built-in redundancy, and a clear pathway toward transition. Lynntech's solution offers a practical, scalable, and transition-ready answer. Thank you for your time and consideration, and please do not hesitate to reach out if you would like further information on this technology or if you're interested in collaborating.